Hi, everyone. I'm David Robinson, Chief Data Scientist at DataCamp, and thank you for joining my webinar, A Day in the Life of a Data Scientist. I'm really excited to be sharing this because it's part of my passion and my job at DataCamp to spread knowledge about what data scientists do and the kinds of tools that we use and the kinds of problems that we face. So I'm going to be sharing what one day of an analysis would be for me, and then I'll be taking questions. So along the way, be sure to ask lots of questions within the GoToWebinar application. So if you're ready, let's get started. So what is a data scientist? It's been my job title for a few years. It's been a very popular job title. And one of the definitions is common for it is this Venn diagram, a combination of hacking skills, so computer programming, math and statistics knowledge, and some kind of substantive expertise. The idea is that if you combine these three kinds of skills, you get what we call data science. There's another definition I really like, and it's by Josh Willis, that says a data scientist is a person who is better at statistics than any software engineer and better at software engineering than any statistician. So all of this kind of fits, but I find it's best to think about what does that actually mean in terms of what they do. This is what skills go into it, but what does a day-to-day life look like? So is it all really exciting, hyped things? Well, I sometimes talk about this hidden revolution in data science, where people often talk about the things that are very hard to do up at the top. These include things like building self-driving cars, or using big data, or perhaps building neural networks that do very advanced machine learning and artificial intelligence problems. So these we would describe as making the impossible possible. And there's a lot of attention on those kinds of technologies. But I'm just as excited by another kind of problem. That's a question of how many people can do something. So that can be everything from visualizing to gain insight into your data set, to using a time series trend to forecast future values. So these kinds of skills are really useful for in terms of people bringing insight to a company. And there's a real revolution in terms of making the impossible widespread. And that's a lot of what has happened in data science in the last few years, is a lot of data science have been able to use these kinds of tools to answer questions for their company. And that's the kind of tool I'm going to be talking about today. So what does a typical day for a data scientist look like? And in particular, I'm going to use this data scientist. That's me, David Robinson, Chief Data Scientist at DataCamp. I'm going to talk about one day in July where I had a question and I went through a typical data science workflow to answer it and communicate my results. So you may have seen this graph before. It's a demonstration of a typical data science workflow. This comes from Hadley Wickham and Garrett Grolleman's book, R for Data Science. So it goes from importing your data to tidying it into a form that you can work with, to a loop of constantly transforming, visualizing, and using statistical models on it. And then finally taking those results and communicating them. And all of this falls within the job of a data scientist. And these are some of the tools that they use while we use while we're working through this process. And you'll be seeing a couple of these tools, the tools we specifically use at DataCamp while I'm solving this problem. So what problem am I trying to solve? Well, what kind of problem would face me at DataCamp? This was a very common one, in particular that I was looking at in July. So I'll share first what DataCamp is. First, we're a company that is all about building an online platform for learning data science. So everything from learning skills to practicing them and then building projects with them. We're most well known for our course interface. So we offer more than 150 courses in Python, R, and SQL that each teach core skills in data science. So every one of these courses is meant to teach some skill, and we're very interested in how do students engage with our product. It's my job to understand how can we understand what courses might be better than other courses, which are more successful in accomplishing their goal of teaching data fluency. So with that in mind, I'm interested in a question. What fraction of people who start a DataCamp course finish it? So this is in education circles known as a completion rate. So it's really important to know it. And it might sound very simple. We're actually going to learn. It's a really good example of the kinds of challenges a data scientist might run into while answering a question that's important to their business. So we're going to start with SQL. SQL is structured query language. It's a technology for asking questions of data. It's one of the first tools a data scientist might pull out of their toolbox. So in the morning when I decided, when I heard from business stakeholders that they were very interested in knowing what's the completion rate of DataCamp courses, I started by thinking, what query can I use to answer it? And this was the really easy, simple query that I ran. This could take maybe a minute or two to write. And all that it's doing is counting people that have completed a course from our database table user courses. And there's a very funny expression that Hadley Wickham coined in this year that's, you can do a lot of data science with counting and occasionally dividing. And look, that's what we're doing here is we're counting two things, counting the number of people who completed, dividing by counting everyone. So we're counting and we're dividing. And for this, I typically use a technology called Metabase. That's a software we use to run SQL queries on our own database. And I might put this query in, run it, and I get out a number. So this would be the first result I ever get, and I got it within a couple minutes of being interested in my question, that 38.7% of people that started a course finished it. So boy, that sounded pretty easy. I guess the data scientist isn't that hard after all. We can just go home. Well, not really. So when we call ourselves scientists, the term data science kind of evokes this idea of science, but the truth is we're often more like detectives. We're very interested in when we get a question, we don't just want a shallow answer. We don't just want to get the fastest answer we can. We're interested in what got to that answer and what might be wrong about it. A lot of data scientists have a background in academic research where it's very common to not just get an answer to a question, but really dig in and make sure we're asking the right question and that we're finding the answer that we're really looking for. So I would start by asking a slightly different question. I don't want to know it overall. I want to know the completion rates of some of the courses that have the most starts. So I want to know of our courses that a lot of people are taking, what are their completion rates? This is then a more complicated query than the first one, though if you know a little SQL, you can still break it down. It comes down to joining some data together, taking our user course data and combining it with data that has the title of it. We do a group by, so we say I'm not interested in overall data, I'm just interested within each course. And then we do an order by. We say I'm interested in the courses of that have the most starts. So I've made my query a little bit more complicated to answer more of a question. And from this, I get a result. These are the courses that have some of the most people taking them. So these include Intro to Python for Data Science, Introduction to R, Intermediate R, and immediately I notice these courses are free. So that means if someone starts them, they might never have taken a course on DataCamp before. They might not be committed to finishing them. Other courses like Deep Learning and Python, you can start for free, but you can't fully finish them. So Deep Learning in Python has a 15% completion rate because a lot of people that started haven't actually paid the money to be able to finish it. So all this is making our original number of 38% a little more misleading. I dig into it a little more and do a little more detective work, and I notice we have other courses like that are partnerships with education companies like edX. So we have courses like Introduction to R and Introduction to Python that have very good completion rates because they're being taken by people that have already done other commitments and already achieved other parts of that course. So overall, all these things are going to be mixing up our conclusion and might not be getting the answer I'm most interested in terms of a typical person taking one of our courses. So now that I know that, I want to refine my question a little bit. This is that loop where I'm always going through transforming, visualizing, modeling, transforming, visualizing, modeling, and always learning a little bit more about my data. In this case, I want to know what fraction of people who start live DataCamp courses and have a subscription end up finishing them. That takes a little more work than my previous query. By a little more work, I mean really all of this SQL code. This is the code I would need to figure out when someone took a course, did they have a subscription at that time? So it actually takes a lot more joining, a lot more SQL logic. And this leads to that classic observation that data scientists make, that 80% of an analysis is cleaning data. So a lot of my work here is not going into something really fancy and exciting. It's answering a question, it's preparing my data so I can properly answer the question I have. But the good news is I didn't have to do that work today because we're able to save all this logic around who subscribed and who didn't for other analyses. In the case at DataCamp, we use what are called materialized views. That means once I've built all this SQL code, I actually store it away, kind of like saving a file, so that I can access the results later. So I had this ready for me, even though it took all the SQL to compute when I did this analysis. So, but this is still really this gives a sense of some of the difficult kinds of data cleaning we might need to do to fully answer a question. Once I've worked with that clean data, the query is still pretty easy, and I get a completely new answer. I say now I find that about 64.6% of people that start a course end up finishing it. So if I hadn't dug deeper, I would have gotten a really misleading number. And it depends all on how you define completion rate, but this is pretty similar to the number we typically use. DataCamp has our courses have very good completion rates by online education standards in terms of more than half of people that start taking a course end up finishing it. So if you're interested in learning how to use SQL to answer your own questions, it's worth noting that we have a series of SQL courses, including an introduction and a course in joining data, and more that'll be coming soon. So DataCamp is one good way to build those SQL skills yourself. We're almost halfway through, so as a reminder, make sure you ask questions as you go, and I'll be really excited to answer them at the end of the webinar. So we've got it now to the middle step. We've answered some of this basic answer. We've gotten one percentage out. Now we're interested in learning a little bit more. What goes into that number? And here's where R comes in handy. So R is the language I most use in my work at DataCamp. Some people at the company also use Python. And both of those are really powerful languages for exploring and understanding data. This is an example of some R code I'd use to get a visualization that lets me dig a little deeper into the question. In this case, this is called a histogram. I wanted to know, how do courses differ in their completion rate? Some presumably have higher completion rates, some have lower. Are they closely clustered together? And this code, let me take a look at this distribution in terms of the higher bars representing more courses in terms across all DataCamp courses. And from that, I learned two things. What I learned is there's a huge variation in completion rates. Some courses have as low as 20% completion rate in terms of when someone starts them, they might not often finish them. And that's really worth knowing for our content quality teams that can figure out how can they make those courses easier to finish. Other courses have as high a completion rate as 85%. So most people that start them end up finishing. But if I dig a little deeper, I learn even more. We organize our DataCamp courses into tracks. And when a course in a track, students will often take a lot of them in a row, which means they'll tend to have very high completion rates. And in this histogram, I was doing exploratory analysis where I said, what's the distribution of courses in a track, shown in red, or not in a track, shown in green? And I can see, in fact, the courses in a track have a much higher completion rate. They tend to range from 40 to 80%, while courses not in a track tend to range from 20 to 60%. So now I've learned a little more and I've gained really valuable insights that I can pass on to the content team about the difference in completion rate between courses. So that was one visualization, a histogram. I might also be interested in understanding uncertainty. How well do I know the completion rate for one course? The problem is that when we have a course that fewer people are taking, we're gonna have a harder time estimating the completion rate. If only 10 people start a course and 6 of them complete it, do we really know that the completion rate is 60%? For that, we want to compute a confidence interval. If you've ever seen polls in the news, this is similar to that, where we'd say, what's a range of possible values it could have? It's like a margin of error. So within every course, I want to know the lower and upper bounds of what the completion rate might actually be. So here's an example of a bar chart I made for 5 of our selected courses. This includes 3 of the ones that I taught as an instructor. And for each of them, we use a confidence interval. We had that's the little red interval where bar where I say it might be as high as this, it might be as low as this. And that gives a sense of how certain we can be about each of these conclusions. For example, we can see that foundations of probability with R and introduction to R for finance. In both of those, we have a lot of uncertainty around what the actual completion rate is, enough that we can't be confident which of those is a higher completion rate than the other. So by understanding uncertainty, we can tell what conclusions we can be confident in and which we can't. This is the realm of mathematics and statistics, one of the parts I showed in that original Venn diagram. So if you're in a statistics course, one might learn this with this kind of math. This is actually the math that goes into computing these confidence intervals. This is called in particular a Klopper-Pearson confidence interval. So if you do my own background was in statistics, so in a course like that, I might learn those things, but the truth is, as a data scientist, we usually don't need to know all the math because we work with tools that make it very easy. For example, the R language has the function binom.test, where I can tell it the number of people that started a course, the number of people that completed the course, and then I can find out a typical confidence interval. So I can find out upper and lower bounds. So I don't necessarily need to know all the math. I can just I can use the tools that R has provided me. And that's how a data scientist toolbox helps make them more powerful. Finally, it's really important when you're a data scientist, especially at a tech company or in business in general, to understand trends over time. So here's where I'd use a little bit more insight. I'm really interested in, has our completion rate been going up over time? Has it been going down over time? And one thing I learned is whether I look at the completion rate, whether it's completing a whole course or completing most of a course, we sometimes use as an internal definition, it might look like it's been going down over the course of 2018. That's why I added a blue bar where I say, what if I only limit it to people that complete the course within 30 days? So that blue line is lower because it's only showing people that complete within 30 days. But think about why I did that. It's because it takes time to complete a course. It could take as long as months or even a year. So if we look at people that started a course recently, it might look like the completion rate is artificially low because they haven't had time to finish it. So that's the kind of problem I ran into when I was thinking about measuring completion rate over time, is I can't find out the completion rate of people who started yesterday. Most of them haven't completed yet. So I can only look at, have we seen a trend over time based on this 30-day window? And overall, it suggests the completion rate hasn't actually been going down among DataCamp courses over time. So those are some of the ways that I took this seemingly simple question and I broke it down a little more so I could understand more about it. Along the way, I used the tools of exploratory data analysis and statistics. If you'd like to learn those tools yourself, almost everything here was done with tools in the Tidyverse collection of packages. That's a group of R packages, including ggplot2 for visualization, dplyr for data transformation, and tidyr for tidying and reshaping data. And we have courses on all of these packages showing how they fit together. And if you take these courses, you can learn to do some of the same kinds of exploratory analyses that I showed in the last few graphs. So by now, during my one day of data science, it's probably 2 p.m. or 3 p.m. And I want to get around to communicating my results. So now's where we move into the technology of R Markdown. I've already been able to show a couple of these results in figures, but I really want to show it in a narrative. I want to write text and have other people in the company be able to read that. That could be everyone from the content team that wants to understand my conclusions to the executive team that wants to get a sense of our completion rate and how they can describe it externally. So R Markdown is literate programming. This was developed largely by Yihui Xie at RStudio, and it's a really exciting technology. What we say is we have some code, and then we have some text, and in the middle of the text, I might say, I might insert a little bit of R code. When I render my R Markdown, this ends up reading like a narrative. I get to read these sentences. So I can say the overall completion rate of DataCamp courses is 60.4%. And I can say if we use the threshold of 85% completion, then the completion rate would be 61.9%. I get to express all these ideas in a narrative that other people can understand while working in code that works fluently for me. So I really enjoy using R Markdown. It's a popular tool among R data scientists. So once I've gotten all my results together, I can't just stick them out as a bunch of figures into the world. I can't even necessarily give them as a talk like I'm doing now. I really need this to be something permanent that other people can refer to when they need it. So I wrote a report in our knowledge repository. There are a lot of technologies out there for this. At DataCamp, we use one called Airbnb Knowledge Repository, which lets us share our reports internally along with their code. So here I spent some time communicating. I spent some time writing up the what my definitions, what counts as completing a course, what counts as a user, all the kinds of caveats that I discovered during this analysis. I make sure I spelled them all out. This is where a background in academic science helps me because it's a little bit similar to writing an academic paper. And I communicate with some evocative visualizations that help get the point across, help people understand what it means for courses to have a high or low completion rate and what kinds of users drive this. So there's really a lot of results that ended up in this report, all around this seemingly simple question. Finally, it's the end of the day, and I've shared this report, but I worry, are people going to be able to fully use the conclusions from it? So this is where we might want to build a dashboard. This is an example of the figure from the report where I wanted to explore every one of our courses and look at how the number of people taking it compares to the completion rate. The problem with a figure like this is it's going to change over time. If I run it today, if I run it tomorrow, it's going to be different. And it's really hard to pick out particular courses. It's not very good at sorting them or comparing one course to another. If someone wants to take a deeper dive, like our content quality team, and understand why some courses have lower completion rate, this isn't the right way to do it. So instead, we use an interactive dashboard. So Shiny is a tool, this is largely developed by RStudio, that for building interactive dashboards entirely within R. So this is an example of our dashboard that we use for monitoring content quality, such as looking at the exercises across one course and how many people end up asking for a solution on them. Our content quality team uses this to find bugs and find questions that can be improved. And because it's interactive, it's very good for having people dig in deeper and deeper and deeper. And in this case, once I learned the completion rate of each course, I wanted to make sure that was expressed in a table. Let people zoom in, search the table, and answer their own questions. There's a snippet of our table of courses from this interactive dashboard. We can find out for each what its completion rate is. Because it's sortable, it lets people find out the answers they need. And because it's a dashboard, it updates every single day. So while a report is very good for a narrative and explaining a story, a dashboard is very good for giving results that change every day, and we want people to dig into a little deeper. So a data scientist has to know when to communicate in a report and when to communicate in a dashboard. And we use a lot of both of them at DataCamp. If you're interested in learning to use Shiny yourself or having your team learn it, there's a full track on Shiny fundamentals with R on DataCamp. So there's a lot of, it is a really exciting technology, and there's a lot that you can do to, data scientists and others can do to build dashboards and learn from it. So in conclusion, I took a tour of some of the data science tools that we use at DataCamp and that all kinds of data scientists that use. We mostly discussed R rather than Python, since that's my own background, but a lot of people will go through a very similar process with Python. In fact, Hugo Baun-Anderson, our data scientist, has a webinar largely about the data science workflow in terms of Python tools. And with a couple of things we didn't cover include, we did statistical analysis, we did exploratory analysis, we did visualization, but we didn't do machine learning. We didn't say if I have X, can I predict Y? Such as if I have this, if I have a particular user, can I predict whether that user will complete a course? We didn't go about the process of productionizing models, taking those models and letting your engineering team use them to improve your product. So those are all other important tasks that data scientists might do. On another day, that might be all that I did. But perhaps we'll cover those next time. Certainly come back if we share another webinar about the machine learning process. I finally want to note something about data scientists, which is that we call ourselves scientists. And as I said, sometimes we act like detectives when we get an answer to a question, but we want to keep digging and finding things about it. But I hope that this presentation got across how much fun it is to be a data scientist, because fundamentally, we're explorers. We're people that get to work within a company and discover all its most interesting problems and challenges, dig into them, find all the nooks and crannies of the data, and then communicate what we've learned to the company and to the world. And it's been a real thrill for the last few years of my career being a data scientist and leading our data science team at DataCamp and seeing many other people learn these skills. John Tukey is often considered the father of data science, though his career was many years before the term was developed. And one thing he said was the best thing about being a statistician is that you get to play in everyone's backyard. And I hope that with this tour, you were excited to try out playing in DataCamp's backyard. Finally, if you're interested in training these skills, everything from exploratory data analysis to statistics to Shiny dashboarding to SQL, you can train those skills using DataCamp for Business. So this is our platform where a company can buy their entire staff our courses that can give data fluency to just like what you've seen here to everyone at your company. So if you're interested, I recommend taking a look at DataCamp for Business. Thank you. So as I've said throughout, I'm really excited to be taking questions and to see what everyone else is interested in terms of a day in the life of a data scientist. All right, so we've started with a really great question from George. The question is, do you have advice on communicating non-conclusive results, especially to non-technical managers? So one of the hardest things about a data scientist is sometimes we have to say no. We have to say this, we ran this experiment and a lot of work went into it, but we can't make a conclusion from it. We can say often perhaps we get a p-value, a measure of statistical significance that doesn't quite hit our threshold. So that's a really big challenge. One of my goals at a company like DataCamp in terms of leading data science is to spread enough statistical literacy that we can communicate these kinds of non-conclusive results in a way that non-technical managers understand it. So someone who's a manager doesn't necessarily, they don't need to be able to use R, they don't necessarily need to be able to calculate a p-value themselves, but they should certainly understand the they should certainly understand uh, the the principles of hypothesis testing, and that you can't, for example, just run 100 tests and then and take all the p-values that are below a certain point and say those are the successful tests. The dangers of multiple hypothesis testing. They should understand the dangers of sequential testing, which include running a test for an extended period of time and waiting for a p-value to hit a particular point. And they should understand the concepts of variation. So the problem that, as I shared earlier, the idea that we don't know exactly the completion rate for a course. It's worth understanding as a non-technical manager to understand the concept of low sample size and wide confidence bounds, so that they don't expect results that are implausible and you can't get. But in terms of as a final, so I'd start by laying the groundwork with non-technical managers in terms of making sure they understand these concepts. For what it's worth, almost everyone at DataCamp starts whether they're a data scientist, an engineer, sales, anything, they take DataCamp courses and they learn some of these principles so that they can understand and appreciate these problems. But one other guide to dealing with inconclusive results is you want to get along with doing the statistical computation, you want to get good at finding similar kinds of data that you can use to answer a question. So for example, if you say we don't have enough data to answer this question, we can't tell, for example, what we can't tell what our user sign-up rate is. We don't have enough people yet. You can start by looking at for say some new feature. You can start by looking at other features that can give you a good sense of it. You can start by using some product logic to discuss, well, we expect it's higher than this experiment, but lower than this experiment. So if you, that's where you start blending your statistical knowledge with your business knowledge. And it takes a lot of experience, just like anything in skill in business does. But that's one of the reasons that substantive expertise is considered a part of the data scientist toolbox. So we don't just have to say, I can't answer that statistically. We can say, I may be able to answer that other ways. All right. So I've got a question from Garrett. That's an exciting one. What was your first job as a data scientist, and how has that day in a life changed over your career? So that's a really, it's actually a very fun story for me. My first job as a data scientist was at Stack Overflow, a programming question and answer website. And I got that job while I was doing my PhD, and I was originally interested in being an academic. But because I'd published some analyses on and answers to questions on Stack Overflow, that the company ended up reaching out to me just as I was starting to look at academic jobs. So they reached out to me, and we started talking and realized it was a really good fit. I tell the full story in a blog post titled 1 Year as a Data Scientist at Stack Overflow. And that blog post also shares what my day in the life was like at Stack Overflow, where I worked for 2.5 years before I came here. And what I'll share about what it's changed is I'm no longer when I was at Stack Overflow, I was an individual data scientist, so most of my days looked a lot like this one I described. Now that I'm leading a team, a lot more of my day is management. I'm in meetings. I do a lot of pair programming with people to help them solve their own problems. I do a lot of planning around processes and structure. So, but I still feel it's very important for someone in my position and as chief data scientist and in a technical leadership role to get hands-on with analyses like these, so I can better understand our own data and guide other people in using it. So that's some of the ways that my day has typically changed. So we got a question from Darren that is, you stated that knowing math isn't needed because of the available computing tools, but would you say knowing the math and statistics helps you be a better data scientist? Thank you, Darren. That's a fantastic question. Absolutely, it makes you a better data scientist the more math and statistics you know. I was very lucky to be a statistics undergraduate major and do my PhD in a statistics lab. So I had a lot of mathematical experience, and I notice that when I'm working with data, I'm able to draw upon that. Even if I'm using simple statistical tests, I'm able to draw on my more advanced knowledge to help know when these tests are appropriate and when they aren't. But I would take that back and say almost everything is useful for a career in data science, but not everything is necessary. And that's one of the great things about being a data scientist is people come into it from different backgrounds. Some people come with a ton of math experience. Some people come with a lot of engineering and programming experience. And some people might have been a product manager or worked in marketing before and bring a lot of substantive expertise. Now, no one necessarily needs all of those skills together, but every one of them can contribute to a strong career. So for me, knowing math and statistics does make me better at my job. But for someone else, knowing how to program in C might make them better at their job, or knowing or having an MBA and a real understanding of business might make them better at their job. So that was my answer. That it certainly helps, but I wouldn't necessarily say it's required. But I definitely encourage everyone to get your hands on as much math and especially statistics as you can, including in our own DataCamp statistics courses. Cool. So I've got a great question from Simon, which is, do you have some good advice on getting managers to understand the business value of data science and machine learning? Absolutely. So I've coined a term, scientific debt. You might have heard of technical debt before. Technical debt is when engineers take shortcuts in building products or building their systems that in the short term work out, but in the long term make the product very difficult to maintain. It might mean that it might be using global variables, or might be using a language that isn't quite well suited to a project. And as a result, it becomes harder and harder to fix bugs and add new features. So this is that invisible technical debt that might build up at a company if you're not always working to reduce it. When I talk to managers, I talk about scientific debt. Scientific debt is when you take shortcuts in your analyses and your reporting, and as a result, you slowly build up mistakes that become extremely expensive to the company. So an example might be if a company takes their sales strategy because they have a particular guess. They think that, well, big clients are more worth the money. But if no one had actually sat down and checked the numbers, maybe it turned out that it wasn't worth chasing big clients because small clients were a more effective use of salesperson time. And until you get a data analyst to spend that time, you might be sending your strategy in a wrong direction. And as you do that, it can end up being dramatically expensive to your business as a whole. The reason I call it debt is that managers often they're focusing on a lot of different roles and a lot of different needs. They're not necessarily interested in what data scientists are excited about or what they want to do. It's really about what will be the cost to a company if we don't do this data science, and putting these costs of taking shortcuts in your analysis, of not building dashboards, of not of using inappropriate statistical techniques. If you explain these costs, most managers will learn to understand them. I have a blog post from May on my blog Variance Explained called Scientific Debt that goes into a lot more detail on this. Okay, so I've got a question from I've got a question that's you mentioned substantive expertise as a part of a data scientist skill set. So how much would you say that part matters in your day-to-day work? So I'll tell you what my substantive expertise is at DataCamp, and that's that I actually taught 3 courses before I joined the company as an instructor. So I have a good feel for how DataCamp's course creation process works and what works well and what doesn't in terms of teaching a course. So when I do analyses of things like completion rate or other measures of content quality, I'm really able to understand I'm able to actually to have some on the ground insight. I'm not and what I notice is when I don't have that kind of insight, let's say if I'm working with a data set on sales and I don't have any sales experience, I find I usually need to be sitting next to a salesperson. I want to always be asking them, how would you interpret this column? How would you does this conclusion feel right to you? What would you think is interesting to look at next? I often do that kind of pairing when I'm working with stakeholders, but it's much more fluent when I have some real experience myself. So I would say the Venn diagram is about right, that there's a sense in which it is 1/3 programming, 1/3 statistics, 1/3 substantive expertise. I don't think it's far off the target on that. I've got a question from Sebastian. Is there an R Markdown-like tool for Python? Yes, absolutely. There's Jupyter Notebooks are a very popular approach for building literate programming in Python. There are some differences in terms of how they're approached, but the fundamentals, if I go back to the slide in terms of having some code and then writing a narrative and having the narrative bring in results from the code is very similar. So it's built by a company called Jupyter, and yeah, those actually do support both R and Python, but my understanding is they're mostly used in Python. And certainly, if you're a data scientist, Python, I recommend getting familiar with them. Cool. All right. So I have a question there's a question from Jim, which is, how do I typically spend my day? What percent of my time is spent in meetings? What percent is spent learning new approaches? So I mentioned before that my job has changed a bit as I moved from a data scientist at one company to chief data scientist, where I need to be spending more time managing and helping coordinate data science across the company. And if you're interested in my role and how it's structured, I recommend my other webinar called Democratizing Data within your organization. So, but I'll share in terms of in particular, I'll share when I was an individual data scientist. I tried to avoid meetings when I was an individual data scientist as much as possible. Since like many programmers, I like working in long stretches on my own. An analysis like I did in this presentation was only possible when I scheduled a day without because I schedule one day a week without meetings. But meetings are very important. Unquestionably important for communicating. Once I share a report, I'll almost always set up a meeting to discuss the results with someone. So you want to have because you do not want things lost in communication during that process. So while I would say data scientists probably don't go, most data scientists probably don't go to a lot of meetings. You also don't want to underschedule them. So let's say a typical data scientist might spend 10% of their time in meetings. That's a very rough guess. I really like that Jim asked what percentage of time is spent learning new approaches. I think one of the best things a data scientist can do to build their career is figure out whatever problem they're currently working on, how can they solve it while becoming better at solving problems like that in the future. So that might involve learning how to use a new software package. It might involve learning a new statistical technique. And this is one reason DataCamp is really valuable within a company, is that you can devote some time every week, let's say one course a week, which takes about 4 hours, and say, what course out of this library of 160 is going to give me a skill that is most useful to what I'm doing now and is most likely to be useful in my future career development. I'd finally end that with a note that getting a PhD is a very good way to spend a lot of one's time learning new skills. Graduate students are expected to spend a lot of their time improving their own skills, and so there's certainly ways to be a very successful data scientist without a PhD, but for people that are considering it, that is one of the values, is spending a couple years where you're spending a lot of time focusing on your own development. So I've got a really interesting question from Susan. Question is, what methods do you use to check that the answer that the SQL code gives is correct? So there are two senses in which it might be correct. One would be what if I'm looking at this in a misleading way? So an example might be, I shared before, when I looked at the SQL code, I ran a query in my SQL database and saw 38% of people completed courses. But at the time, I didn't realize that I was looking at people that had subscriptions, didn't have subscriptions, old courses, new courses, all lumped together. And so I was getting a misleading number. So the way to discover whether that's the case is to do what I did in this blog post, to do what I did in this webinar, which is to segment the data, to look at it by month, to look at it by course, and watch, and always have a suspicious eye watching for things that don't fit. But another kind of way a result can be incorrect is what we'd call data integrity issues. What if there was a bug on the product side that said suddenly one day completion stopped being recorded? Like every time someone completed a course, it didn't actually get saved into the database. Users might never notice that bug, and data scientists might not notice it if they're not looking for it. That kind of problem, data integrity issue, is very serious, and it can be found either through the kind of exploratory analysis I did here. You can spot it when you have suddenly a completion rate goes down to 0 and you're not sure why, or it can be found through automated testing. So this is a relatively new and exciting area within the field of data engineering, of automated testing of data. There's been automated testing of software for a long time. It's very important in the engineering community. But data scientists and engineers have started to appreciate the importance of automated testing of data to see that it fits our assumption. I've seen one exciting project called Great Expectations that attempts to do unit testing on data. And we're starting to experiment with implementing that at DataCamp and looking at alternative approaches. So it's a really interesting question to think about data integrity. And yeah. So I'm looking, let me see. So I had a specific question from Amik, and the question was, why do some courses have wider confidence intervals than others? That was back on this bar plot. How does where does the extra uncertainty come from? So this is exactly the kind of concept we love to spread all across a company, because it's very important to understand. When fewer people start a course, we end up with more uncertainty about how many finish it. So an example would be, imagine 2 people started a course. Say it wasn't a very popular course. 2 people started it, and neither of them completed it. Does that mean that the completion rate is 0%? Well, it's our best guess, but no, we have so much uncertainty. Maybe the completion rate is 80%, but these 2 people happen not to complete it. So there'd be a lot of when the sample size is small, there's a lot of uncertainty. But what if we had 10 million people starting a course and then 6 million of them finish? then we get to be very certain. We get to have a very small confidence interval. We know that the completion rate is very close to 60%. So the answer is that uncertainty comes from low sample sizes. That's always worth understanding in a business context, because sometimes people want to try and make conclusions, let's say in the first couple months of a startup, or when a product gets launched, or for a feature that not a lot of people use. And we have to understand that it's hard to detect those, it's hard to measure those accurately because of the low sample sizes. I got one other specific question that's fun, which is from Simon. What is the theme that I used for the visualizations in the R Markdown report? So this is a theme called GGDC for ggplot2 DataCamp. It's built internally within the company by our VP of Product Research, Ramnath. It fits our DataCamp color scheme, which is the reason we use it. I don't think, unfortunately, it's publicly available, but maybe we should if someone wants to make DataCamp themed figures. But that's a useful bit of consistent branding across a company to keep plots having a similar theme. I have a great question about Hussein, which is, do I use SQL more than Python? Personally, I do. I use a lot of R. I use a good amount of SQL, and I use some Python. I think it's very difficult. I wouldn't say impossible. It's very difficult to be a data scientist at a tech company today without using a lot of SQL. See, it's an extremely common technology and an incredibly powerful one for getting questions out of data. So I certainly use a lot of SQL myself. For Python, the places that I use Python are for data engineering. Within DataCamp, if I need to move data from one place to another, if I need to schedule processes, all of our workflow for that is in Python. And I often jump into that to help guide some of the data so it can be better arranged and organized. And I also work with we have a machine learning engineer, Vincent, who uses Python, and I work with him to develop machine learning models for a product, and he works in Python, so I do some Python work for that as well. But the vast majority of my analyses are R, and I use a lot of SQL because we're constantly working with databases. So Python is a little bit more of an exception, but of course that balance is going to vary. All right. Here's a neat question from Bruno, which is, in your example project, when you looked at course completion, were you as the data scientist involved in the executive conversations pertaining to improving the completion rates? So I'm in a very interesting position because I am an executive. As chief data scientist, I report to the CEO and I get to join in on a lot of the executive conversations. We do that at DataCamp because we really value the role of the data science team, and we want to make sure the perspective is always heard. So we want to make sure that in an executive meeting, if we're discussing, say, some of the product goals for the company, we want to make sure that there's that we always have data backing it up. And having me in the room, and I'm working closely with all the data scientists involved, I often get to I get to have those conversations. But in general, yes, it's worth. It really is worth bringing in the data scientist as high as possible into like a large conversation. That could be, so anytime there's a particularly interesting or important result, it's worth looking at how can this be communicated as effectively as possible to people that have as much decision-making power as possible. It's different within every company, and it depends on a lot of factors, but I've found most companies fall on the side of under communicating rather than over communicating data science results. That is, it's always worth getting the data scientists into a meeting with people to whom they can explain their conclusions. I finally noted to have with that was we actually have we were very happy. We've been very happy around our completion rate for a while. It is much higher than the industry average. So we're always looking for ways we can improve the completion rate. But I want to make sure I share we don't consider it we consider it a point of pride for DataCamp that well over 60% of people that start a course finish it. So let's see, I have time for one more question. Let's see. And yeah, my last question is, how do you see the field changing here in the recent future? Are you seeing a different type of subscriber? Are you uncovering other trends in the data science field from our data? One thing I can say from our data is that machine learning and especially deep learning is very exciting. There's been an explosion of people taking courses and really interested in taking our machine learning material. So we can see that in a lot of trends outside our company as well. So I think I think there's no question that that continuing to make the possible widespread in machine learning. That is taking the methods that are already well understood and spreading through a wider and wider group of people that can get to implement them is a really is going to be a really big part of the next couple of years. Having said that, I want to finish by returning to one of my opening slides where I share what I think is the most exciting future, which is not the hardest things that can be done, but the basic tasks, the same kind I talked about today: exploratory data analysis and visualization, understanding and interpreting models, understanding trends over time. My view is getting these kinds of insights. I think the appreciation is rapidly growing within the field for how much that is a part of the data of the machine learning conversation, and I think that'll continue to grow. So thanks everyone for joining the webinar. I was very excited to have you and to share one day in the life of a data scientist. So thank you.